Hi guys, may adlaw. Kumusta? I hope you are doing fine and still coping to the demands of this continuing education. We have this technology to use to advance our education, especially in mathematics. So for this video, I will be presenting to you about solving logarithmic inequalities. This is the continuation on the lesson about solving logarithmic equations. So I hope you have already watched the video about solving logarithmic equations because this is the continuation of the lesson. So before we proceed, we only have one lesson objective, which is at the end of this video, you should be able to solve logarithmic inequalities. This lesson requires us our prior knowledge in the following. Number one, you have to have our knowledge on the laws of exponents. Number two, you have to have our knowledge on the laws of logarithm, then solving logarithmic equations, and writing an interval notation. So to start, let us have the rule first. For solving logarithmic inequalities, we have two rules to follow. So the first rule is that if the base is greater than 1, and we are given this inequality, and this base is greater than 1, this goes to follow that if log of x base b is greater than log of y base b, then we can say that x is greater than y. We need to remember that x and y here have restrictions, meaning our x should always be greater than 0, the same as with y. These are our restrictions. We will have an examples on how to do the restrictions later. So again, we have our restrictions for x and y here. X and y must be greater than 0. Again, if the base is greater than 1, the sign here are not changed, meaning the sign is the same. For the second rule, if the base is in between 0 and 1, meaning the base is less than 1 but greater than 0. So this inequality can be written as log of x base b is greater than log of y base b. Our x and y can be x should be less than 1. So as you have noticed, the symbol is changed. Still, our x and y here has restrictions. So x and y must always be greater than 0. Okay? So take note of these rules because we will need to follow these rules in our examples later. Okay, let's proceed to example number 1. Log of x plus 4 base 2 is less than or equal to 3. As you have noticed, on the right side of the inequality, we only have the whole number 3. While on the left side of the inequality, we have log of x plus 4 base 2. And as you can see, the base here is 2, which is greater than 1. So meaning, we will follow the first rule. But before we apply the first rule, we need to express the right side of the inequality to log form first. Meaning, we have to have a log here so that we can apply the first rule. So how do we do this? So solution, we can write this one as log of x plus 4 base 2. We copy this left side of the inequality. Then we copy the symbol less than or equal to. Now the right side of the inequality becomes 3 log of 2 base 2. Now question, where did we get log of 2 base 2? The concept here is that we just simply multiply 3 by 1. Meaning, when we multiply 3 times 1, it is 3. Okay, so meaning, we did not change the value of the right side of the inequality. Log of 2 base 2 is just equal to 1. Now, why did we use log of 2 base 2? Because our base here at the left side of the inequality is 2. So our focus must be that the base in both sides or the log in both sides of the inequality must be equal. The base of the log in both sides of the inequality must be equal. If this is 2, our base here is 2. Now, to make this log equal to 1, so our power here must be also 2. So, to prove that log of 2 base 2 is 1, so we can write this one as, we can prove this one like this. So, log of 2 base 2 equals x. Let us assume that we still do not know about the value of log of 2 base 2. That's why we equate this one to x. So what must be the value of x? So now, since this is an equation, we equate na to. So since this is an equation, we can solve for x by changing this logarithmic form to exponential. So when we write this one to exponential, we can have 2 raised to x equals 2 raised to 1. So how did we get this one? We have the base here is 2, this one, this is the 2, and we have here the exponent, this is the x, is equal to the 2 here, this is the 2, and since 2 is assumed to have exponent 1. So since we have 2 equals, we have the base 2 here, which are equal, so meaning we can equate the exponent x equals 1. So therefore, x equals 1. Therefore, to conclude, log of 2 base 2 is equal to 1. So meaning log of 2 base 2 is equal to 1 is saying na siya that when we multiply 2 times 1, so we did not change the value of the right side of the inequality. It is just equal to 1. The purpose is that so that we can apply the first rule of the of solving logarithmic inequalities. So we now have log base 2, but before that, we need to express this side of the inequality using the power law. So since we have the 3 here, so meaning this 3 becomes the exponent of 2 here, we will apply the power law. So therefore, we copy the side of the inequality, log of x plus 4 base 2 is less than or equal to log of 2 cubed base 2. So as you have noticed, the 3 here becomes the exponent of 2. We apply the power law. This time, we can now apply the first rule. We will leave the log base 2 here and we continue these expressions without changing the symbol because our base is greater than 1. So we apply the first rule. We can write this one as x plus 4 is less than or equal to 2 cubed. Okay, we have here the 2 cubed. We will leave now the log here. We will continue with x plus 4. Then we copy. Then we have 2 cubed. Now we simplify. 2 cubed is equal to 8. So we just simply copy x plus 4. This time we have the positive 4 here. To eliminate the 4, we need to subtract 4. We need to subtract 4 at the right side by subtraction property of equality. So what remains on the left side of the inequality is x is less than or equal to 8 minus 4. So meaning x is less than or equal to 4. Okay, so this is now our inequality. Now let's go to the restrictions. As I have mentioned earlier, that our power here has restrictions. So this value here must be greater than 0. So these are our restrictions because it has something to do with the solution set of our inequality. So x plus 4 must be greater than 0. To solve for the restriction, we have x plus 4 should be greater than 0. So by subtraction property, we can have x is greater than negative 4. Now, to find the solution set for this inequality, we need to illustrate these inequalities, these two inequalities in the number line. So our first inequality, x is less than or equal to 4, and the second inequality for the restriction, which is x is greater than negative 4. So if we are going to illustrate this one in the number line, we have this number line for example. We illustrate first that x is less than or equal to 4. Now take note, this is less than or equal to 4. Since this is less than or equal to 4, we will use solid dot here, meaning shaded point because of the equal. That means that 4 is part of the solution set. So if we have this number line, this is the number line, we have here the positive 4, so meaning our point is located here. So to illustrate the point, this is now solid, of course, because of less than or equal to. Now, x is less than or equal to 4. So this is our positive 4. Since less than, so this side are the values less than 4. So our arrow goes to the left side of the number line. Our line goes to negative infinity. The arrow indicates infinity. So from positive 4 to negative infinity including 4. That is our x is less than or equal to 4. Now for the second inequality, which is x is greater than negative 4. X is greater than negative 4. So we locate our negative 4 in the number line. For example, this is our negative 4. And because this is greater than, we will use hollow dot or a point or not shaded point. Meaning this is a hollow dot. This, this means that negative 4 is not part of the solution set for this inequality. Okay? So our arrow goes to positive infinity. Now, we have here the region for both inequality. We have here our first boundary, and this is our second boundary. The solution set for this inequality shall be the region containing the common solution set to both inequality. Meaning, kaning region diri dapita nga naa silang duha nga inequality kining duha ka linya from this point here up to this point, because beyond this point we only have this line, and beyond this point we only have this line. We need to take the region containing the solution set of both the inequalities, the first inequality and the second inequality. So we have this solution set from this point, from this boundary up to this boundary. The solution set for this inequality shall be negative 4 up to positive 4. Now take note of the symbol. This is a parenthesis because negative 4 is not part of the solution set, which is being represented by a hollow dot. Up to positive 4, this is a brace because 4, positive 4 is part of the solution set that is being represented by this solid dot. Or we can write the solution set like this one. Okay, let's proceed to the second example. For example, we are given this inequality. Log of 2x minus 6 base 5 is greater than log of x plus 1 base 5. Still, our base is greater than 1, so we need to follow the first rule. So therefore, we can write this inequality as 2x minus 6 is greater than x plus 1. Without writing now the log, we apply the first rule. And of course, without changing the sign, greater than. And we have to remember also about the restrictions. So this 2x minus 6 should always be greater than 0. And this one also, x plus 1, should be greater than 0. So later we will be solving the restrictions. But for now, we will continue. So 2x minus 6 is greater than x plus 1. So by subtraction property for x, we copy 2x, the 2x copy, subtraction property, so we subtract 4, we subtract x here, of course we will also subtract x at the left side of the inequality. Then we copy 1, since this is negative 6, we will use addition property, so this is plus 6. So 2x minus x is x, then 1 plus 6 is 7. Now for the restrictions, we have 2x minus 6, so 2x minus 6 must be greater than 0. Okay? So subtraction, this is minus, so meaning we need to use addition property. So this becomes 2x is greater than 6. So we copy 2x, addition properties, this becomes positive 6. Now divide both sides. To eliminate the 2, we need to divide both sides by 2. So therefore, x is greater than 3. For this restriction here, which is x plus 1, so x plus 1 is greater than 0. Subtraction property, x must be greater than negative 1. So as you can see, we have three inequalities here. X is greater than 7, x is greater than 3, and x is greater than 1. So if we are going to illustrate these inequalities in the number line, we need to illustrate first x is greater than 7. So if this is our number line, our 7 is located here. So since that is greater than, wala na siya equal, the same ani wala equal, greater than or equal to. So if this is the case, we need to use a hollow dot or a unshaded dot. So a hollow dot. So this is positive 7. Now since this is greater than, our arrow goes to positive infinity. Okay, greater than. Now let's proceed to the second inequality. X is greater than 3. So we locate the positive 3. Our positive 3 is located here. Still, this is greater than, so meaning this is a hollow dot. Still, our arrow goes to positive infinity. Now, the third one. X is greater than negative 1. So this is our negative 1. Still greater than, so we need to use a hollow dot. And our arrow goes to positive infinity. We need to use this boundary here because of this region which is common to the three inequalities. So the three inequalities coincide starting at this point here. Take note, so if we are going to shade our solution set for this inequality, we can have this solution set. Now, to write the solution set for this illustration, we can have 7, which is this one, 7 until positive infinity, or x is greater than 7. So from this boundary up to positive infinity, or x is greater than 7. Let's proceed to example number 3. Now this time we are given log of 3x plus 5 base 1/3 is greater than log of 2x minus 3 base 1/3. This time our base is 1/3, which is less than 1 but greater than 0. So we need to apply the second rule. So to write this inequality applying the second rule, the greater than becomes less than. Okay, so we leave the log here. We copy 3x plus 5 and 2x minus 3. But this time, our symbol, instead of greater than, our symbol becomes less than. Okay, so to solve now for x, we copy 3x and we use subtraction property for 2x here and also for 5. So we can write, we copy 3x, subtraction property, that becomes negative 2x. Then also we copy negative 3, then this becomes negative 5. So to continue, 3x minus 2x is x is less than negative 8. So x is less than negative 8. This is our first inequality. Let's proceed to the restrictions. So the first restriction is 3x plus 5. So 3x plus 5 is greater than 0. Solve now for x, use subtraction property, so this becomes, we copy 3x, then this is greater than negative 5. Then divide both sides by 3, so this becomes x is greater than negative 5 over 3, which is equal to negative 1 and 2/3 in mixed number. So x is greater than negative 1 and 2/3. This is now the second inequality. Now the second restriction, 2x minus 3. So we can write 2x minus 3 greater than 0. So again, 2x minus 3 must be greater than 0. This time we have negative 3. So we use addition property, we copy 2x. Then 2x is greater than 3. So negative becomes positive by addition property. And divide both sides by 3. So this becomes x is greater than 3 over 2, which is equal to 1 and 1 half. Now we have three inequalities now. Illustrate these inequalities in the number line. For example, this is our number line. We will illustrate first x is less than negative 8. So this is our negative 8. Since this is less than, so the dot is hollow. This is hollow. Then our arrow goes to negative infinity because we are using the less than symbol. Next, x is greater than negative 1 and 2/3. Approximately greater than. So approximately this is our negative 1 and 2/3. So our negative 1 and 2/3 is approximately on this point here. Not equal to negative 2, but approximately near negative 2. Duol sa negative 2. So still, this is greater than, we use a hollow dot. Then, since greater than, our line goes to positive infinity. So the two lines goes in opposite directions. Now let's proceed to the second inequality. X is greater than 1 and 1 half. So where is 1 and 1 half? Positive. 1, this is 2. So our point is located in between 1 and 2. Still, we use a hollow dot because this is greater than. Now, since this is also greater than, our arrow goes to positive infinity. Now, this time, since we have one inequality here that goes to negative infinity, meaning there are no way wherein there is no chances that these three inequalities will coincide. Meaning, kini silang tulo, dili ni sila, walay paagi nga kini silang tulo mag-coincide. Because we have one inequality that goes in opposite direction. We only have two inequalities that coincide starting from this point here, from this boundary towards positive infinity. So if this is the case, if the three inequalities do not coincide, we can say that this given inequality has no solution set. So meaning there is no solution to this inequality. Okay, let's proceed to the last example. For example, we are given log of 2x minus 5 base 4 is greater than or equal to log of x minus 5 base 4. Okay, again, our base is greater than 1. So we will apply the first rule. We will not change the sign. So in solution, we can write this inequality as 2x minus 5 still greater than or equal to x minus 1. Again, the symbol is not changed. Again, we copy 2x and we use subtraction property for x and addition property for 5. So we can write the inequality as 2x minus x, which is this x, is greater than or equal to, we copy negative 1 and we use addition property that becomes plus 5. To simplify, we have 2x minus x is greater than or equal to negative 1 plus 5, which is positive 4. So this is our first inequality, x is greater than or equal to 4. For the restrictions, the 2x minus 5 should be greater than 0 at the same time also with x minus 1 should also be greater than 0. So let us have first the first restriction. 2x minus 5 should be greater than 0. So by addition property, this becomes 2x is greater than 5 and divide both sides by 2. We cancel out the 2. So what remains is x. Then 5 over 2 is 2 and 1 half. Okay, this is the second inequality. For the third inequality, we have x minus 1 is greater than 0. So by addition property, this becomes x is greater than 1. So illustrate in the number line. This is our number line. We will locate 4 in the number line, positive 4. This is our positive 4. Then is greater than or equal to, meaning we use the solid dot. Then our line or our arrow goes to positive infinity. For the second inequality, x is greater than 2 and 1 half. So this is positive 2 and positive 3. So our point is located in between 2 and 3 because of 1 half. But this time, the symbol is greater than, so our point should be hollow or unshaded point. Still is greater than, the arrow goes to positive infinity. Now let's proceed to the third inequality. X is greater than 1. So we locate 1, positive 1 here. So this is our positive 1, then greater than, so our hollow is unshaded. Then our arrow goes to positive infinity. Now let's check the boundary. We have our boundary. Our three lines coincide starting on this boundary. The three lines coincide starts at this boundary. So meaning, our solution set starts at this boundary from positive 4 towards positive infinity. So to write the interval notation for this illustration, we can say that the solution set for this inequality must be 4 up to positive infinity. We use the brace because 4 is part of the solution set because of this solid dot. Or we can write the solution set as x is greater than or equal to 4. So that's it. Before I go, let us have first this practice. So try solving these inequalities, applying the rule, and also the examples that I had presented. So we have 1, 2, 3, and 4. Thank you and God bless. And please do not forget to subscribe, like, and share to your friends, especially those incoming grade 11 students.